Recording in progress. Ruchali ma'am, sir has not joined yet, na?
No, ma'am, he has not joined it.
मैं कॉल करती हूँ उनको just.
हाँ.
Okay. 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 நான் வீட்டுக்கு வந்துட்டேனே. ஆமா.
Madam, sir has joined.
Okay, madam.
Ma'am, can we start then?
Sir, can we start?
Yes, we can start. Just a
Good
minute.
afternoon, sir. Yes, sir.
Good afternoon.
Yes, Shweta ma'am, we can.
Yes, yeah, ma'am. Ruchali ma'am, can we start now?
Yes, ma'am.
I think we should wait for 2-3 minutes.
Okay, madam.
Okay, okay.
Shweta madam, let's start.
Yes, madam. Okay. Good afternoon, everyone. I request everyone to raise yourself for national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे
very good afternoon, everyone. I am Professor Shweta Sato from Computer Science Department of Bharat College of Arts and Commerce. Welcomes you all for ICSSR sponsored 10 days national level training and capacity building program on research methodology. Today is the 9th day of the program where we have an eminent personality, Dr. Chirag Malik, with us. Yesterday, sir has discussed about the non-parametric tests, and today, sir will be enlightening us with the hands-on training on research methodology using SPSS. Welcome, sir, again on this virtual platform for your second session, sir. Over to you, sir.
Thank you so much, Shweta ma'am. Thank you so much for your kind words. So let me start with where I left yesterday. So before starting, in case if anyone has any query, any question, please ask, so that we should not carry our doubts further. Yes, no one. So let's start with where we left. So let me first share my screen. Yes, so this is the data set that we actually worked on yesterday. Just a small part that we have worked on. Okay, and this data set is basically of a demographic nature. So most of the variables are the demographic profiles. Okay, so in case you have any other data other than this demographic data, you can also work on that as well. It's just a kind of example. So if I look at this particular PPT, and we started with the very first test, and that test was 2 independent sample t-test. Okay, so since this particular test was being done when all the assumptions are being met. Okay, but now what if assumptions are not met? So we actually did Mann-Whitney U-test. And the beauty of SPSS was that even if you do not know which particular test is being applied, you just have to fill the fields with their respective variables. You don't have to even decide the test. Okay, and SPSS on its own will choose the appropriate test for those particular variables. So that is the best thing that we have, but that is only in the case of non-parametric test. Okay, so now going further, so let's first again repeat the same thing that we did last time. Okay, that is in the last class. So that what was that? So we actually did the t-test on, and we really wanted to see the relationship between two variables, age category and weight. No, gender and weight. Okay, so we just wanted to find out whether there is a relationship between gender and weight. Now what does that mean? Relationship between gender and weight. It means that whether gender influences the weight or not. It means this. So this is one and the same thing if we say there's a relationship or the influence, because in case if there is no relationship, there is no influence. It's very simple. So, and if there is a relationship, it means influence is there. Simple. So this we need to presume. Okay. So if I want to see whether gender and weight are related, it means that I want to see whether weight is being influenced by gender or not. This is the simple meaning. Okay. Now, since gender is a categorical variable and weight is a continuous variable. Okay. So this is continuous. Continuous means what? Means either interval or ratio scale. Or ratio scale. And gender is a categorical variable. Means either it is nominal or it is ordinal. Okay. So right now, this is not nominal. This is nominal, not ordinal. Okay. This is nominal, not ordinal. Okay. So this is categorical and this is continuous. And I want to see the relationship. So very simple. If one is categorical variable, the other is continuous variable, and the categorical variable has just two categories, we do t-test. But in case if the t-test cannot be applied because the assumptions are not met. So क्या assumption है? The first and the foremost assumption that we all should check is normal distribution or not. Normal distribution. So since when I asked that, do you know how to check normal distribution? That is the normality of the data. So no one actually, people said, they have not done it. So let me tell you quickly how to test the normality of the data. How to test whether a particular variable is normally distributed or not. One thing you need to be very careful is normal distribution should always be checked for continuous variable. Okay. Not for nominal. There is nothing called normal distribution for categorical variables. Okay. Okay. So what is normal distribution? This is probability distribution. Probability distribution. Okay. This is how you actually work. So you actually see the probability and see the curve. If the curve says that yes, it makes a very good bell-shaped curve, then it is normally distributed. You may actually have a question that, sir, why do we need a normal distribution? It's very simple. If you need to answer this question in a very simple form, then the only answer, only simplest answer to this question is, if the data is not normally distributed, the results of this particular sample cannot be applied on population. Means the results cannot be generalized. And if the results cannot be generalized, then why should we work on this sample? What is the purpose of actually using this sample? Very simple. Okay. So it's very clear. Just a minute, just a minute. Okay. So I would like to see, so if I really want that I should apply the results of my sample onto population, it has to be normally distributed. My sample has to be normally distributed. Very simple. Chaliye. So let me also tell you how to test the normality. So since gender and weight, okay, are two variables within which I actually need to see the relationship. So which particular variable I should go to check the normal distribution? Weight, because weight is the continuous variable. Okay. In case if weight is normally distributed, then I should go for t-test. But what if weight is not normally distributed? Then I will not go for t-test. Then I'll go for Mann-Whitney U-test. That is non-parametric test. Very simple. And now, yesterday we did non-parametric test as well. Okay. So let me first tell you and show you how to test the normality of the data. So let's test the normality of this particular variable, that is weight. So go to analyze, go to descriptive statistics, and go to explore. Okay. And in explore, in the dependent list, in this particular field, put the variable for which you would like to see the normality of the data. Okay, so you would like to see the normality of weight. So here you don't have to do anything with this particular tab, which is called statistics, where descriptives is being given. Okay, just see the plots. Go to the plots and see here, press on normality plots with tests. Just check this particular box, normality plots with tests. Okay, and then press continue and then say okay. Okay, so let me do it again in case if you have skipped. Okay, go to analyze, go to descriptive statistics, go to explore. In explore, put the variable for which you want to check the normality. So here in this case it is weight. So weight is being taken to the dependent list in this particular field. And then I will not do anything with this particular tab, that is statistics. I will go to plots, press on this. I'll check this particular box. Okay, you will find like this. Okay, now remove stem and leaf plant. I don't need it. I don't need histogram as well. However, you can always see the histogram if you really want to see the histogram and you would like to see the normality plots with test. So just see the histogram as well. Okay, the plot which I just made is a histogram. So just press continue and then press OK. So this is the case summary, that how many missing values are there and all. Okay, this is the descriptive statistics. If you see mean, okay, 95 confidence interval of mean, 5% trimmed mean. 5% trimmed means is in case if there are outliers, the outliers will exist only in extreme cases, either on the lower side or on the higher side. What if we remove the 5% cases, means 2.5% cases from the lower side and 2.5% cases from the higher side? And what remains, whether that is equal to or similar to the mean or not. So it means outliers are not there in case if results are not very much different if we take 5% trimmed means. So that is the meaning of 5% trimmed means. Okay. And then variance, standard deviation, minimum, maxima, range, interquartile range, skewness and kurtosis. Okay. So these values are there. So see, this is the test of normality. So how these results are being, read for normality. Normality may we have 2-3 tests. So here, by default, SPSS gives 2 tests together. One test is the Kolmogorov-Smirnov test. Okay. And the second is Shapiro-Wilk test. So 2 tests, Kolmogorov-Smirnov test, and the second is Shapiro-Wilk test. So 2 tests are there. So how to read the results of these tests? So the result is, this is the statistic value, okay, and this is the degree of freedom, and this is the significance for Kolmogorov-Smirnov test, and for Shapiro-Wilk, this is the significance. Significance means p-value. And I told you, whenever there is p-value, there is some hypothesis as well. So here in normality, what is the null hypothesis we take? We take as nothing is changed. Status is status quo, means data is normal distribution. Data is normal or normally distributed. So this is the null hypothesis that we have taken.
Sir,
So
can you
whenever
repeat this
we
last
will be-
sentence?
Sorry,
Can you repeat this last two sentence?
what
You,
is
yes, you have confirmed this. Na? It is not. It is a normally distributed. How it is normally using this p-value?
I'm telling you. See, whenever we test the normality of any data, we first formulate a hypothesis. Okay, either you make null hypothesis or alternate hypothesis. So since we are it's easier for us to interpret the results on null hypothesis, and yesterday also we worked on null hypothesis, so that's why we are making null hypothesis. And what is the definition of null hypothesis? The definition of null hypothesis is nothing is changed. Status is status quo. Nothing is changed. So this is the definition. Okay, nothing is changed. Status is status quo. Means, what does that mean? It means no action required. No action required. Okay, which means nothing is related to each other. Nothing is related. इस तरह से होता है. Okay, it means भगवान की बनाई हुई सृष्टि में सब कुछ इंडिपेंडेंट है और नॉर्मली डिस्ट्रीब्यूटेड है. ठीक है, तो ये नॉर्मल डिस्ट्रीब्यूशन हम मान के चलते हैं नल हाइपोथेसिस, दैट नथिंग इज चेंज्ड, एवरीथिंग इज नॉर्मली डिस्ट्रीब्यूटेड. सो ये हमने हाइपोथेसिस हम हमेशा बना करके चलते हैं. ओके, सो व्हाट वुड बी द नल हाइपोथेसिस for testing the normality of the data? That data is normally distributed. This is the null hypothesis that you actually have to formulate. Okay, ये आपने बना दिया. अब now I want to test this hypothesis. So that is why Kolmogorov-Smirnov test बोला जाता है इसको. Okay, Shapiro-Wilk test बोला जाता है. किसको टेस्ट करते हैं? They test the hypothesis that you have created for yourself. And yesterday we have learned that how to test the hypothesis with the p-value, है ना? और हमने yesterday we have also learned p high, if p high, null fly. If p low, null go. That is, we have learned yesterday. So it's very simple. So here, if you see here, p-value, it is less than 0.05, which means null hypothesis p low, null hypothesis rejected. But here in Shapiro-Wilk test, it says p is greater than 0.05, where null hypothesis is accepted. So this is really a very difficult situation where null hypothesis rejected means data is normally distributed. Rejected means data is not normally distributed. But the another test says the null hypothesis is accepted, means data is normally distributed. Now you will get confused. How is it possible? Now it is possible. The tests are there in front of you only, and we have the data. It happens sometimes. So what should we do when one test says data is normal distributed and the another test says data is not normally distributed? Okay. In this case, various authors and research papers say that you need to report two incidences, two tests, wherein you need to either say that the data is normally distributed or not normally distributed. There should be two tests at least. So here we have done two tests, but one test says this and one test says the opposite. So it means that let's do the third test. Now the best part is third test has already been done by SPSS itself. And the third test is here, if you see. This is called normal QQ plot. Okay, QQ plot. Now what this quantile plot says, so how to read this particular plot. This plot says if you find maximum number of observations either on the line or very near to the line, you can always consider data as normal. Now again, I'm telling you how to read QQ plot. If you see the observations very near to the line or on the line, not like this. Okay? So it means that there is problem. Okay? So the data has to be on this particular line or very near to, because absolute normal distribution तो कहीं मिलता ही नहीं है. Okay? वो ideal situation होता है. So this, in case if I say this, so most of the observations are very near to the line or on the line. So I would say I can consider data as normal distribution. So if you see this, so I have test number one, this where null hypothesis is accepted, and the test number two, which says that data is normal. So this is 2. So that was 1 and this is 2. So this is how you can actually talk about the normality of your data. Now there is another situation as well. You may also try to make your data normal distribution. ये कैसे हो सकता है? वो कैसे हो सकता है? You can take the log of your variable and then do the normality test of that particular data. So take the log or take the inverse or take the log of inverse and see if the data is normally distributed or not. In case if with the log the data comes as normal distribution, even then we can go for parametric test like t-test or ANOVA. So how to actually convert, how to take the log of the values, you must know. Okay. So in case if I want to take the log of this particular weight and create another variable, which is log of weight, how it can be done on SPSS? Very easily. Okay, just see. Go to this particular tab, which is called transform. Can you see that? There is a tab called analyze where you actually get all the analysis and techniques here, Hana? But these tabs, which tabs? These transform, data, view, these tabs are not related to any analysis. This is just for the data manipulation. This is for data management. These tabs are for data cleaning. Okay. So then go to this, just press transform, and you want to create another variable, Hana, which is the log of weight. So there is very first, option here, and which is compute variable. Wonderful, tab here, and wonderful feature of SPSS where you can compute new variables. Just press on this. Now, if you see this, okay, if you see this particular dialog box, so this dialog box is as good as a calculator. It has got all those functions which you can also find in Excel as well. Okay. So here are the variables. Okay. So target variable. So I want to create target variables, the new variable which you want to create. So I want to create log of weight. So this is the name that I have given to this particular variable. And now, so the new variable which would be created will be named as log of weight. Okay. Now I would like to take the log. So how can I take the log? So I'll press here arithmetic, and then I'll search here, where is the log? This is log 10, this is natural log. So I'll press this natural log here, and then I would press this arrow that let's take this log to this numeric expression here. So now the log of, now it's showing the question mark. Log, natural log of what? So I would say weight. So take weight here. So see here. So natural log of weight. So do the numeric expression, do apply this formula, natural log of weight, and create a new variable, which is log of weight. Okay, this is the name of the variable. You can give any name, any name. Okay, so don't worry. You don't have to write log of weight, but since it is better for us to understand what we have done with this particular variable, you can give good name which is understood to you as well. So log of weight. So let me say okay. Okay, so new variable has been created, it has been executed. Let's go and see the SPSS file. And here is the SPSS file. Yahoo, great. Log of weight. So this is the new variable that I have created for myself. So why we have done this? Why we have taken the log of weight? Because I want to make this particular variable a normally distributed variable so that I can apply the parametric test. That is, what are the parametric tests? T test और F test, है ना? अब आपका ये प्रश्न हो सकता है कि सर जब नहीं हो रहा तो नहीं हो रहा ना, छोड़ो पैरामीट्रिक टेस्ट को, कर लेते हैं नॉन पैरामीट्रिक, क्यों उसको नॉर्मल करने की जरूरत है, क्यों ट्राई कर रहे हैं हम, है ना? ये प्रश्न हो सकता है आपका। तो सुनिए, पैरामीट्रिक टेस्ट बहुत रोबस्ट और पावरफुल टेस्ट होते हैं, बहुत रोबस्ट होते हैं। ओके, नॉन पैरामीट्रिक टेस्ट के कंपैरिजन में, ठीक है? जब कोई चारा ना रह जाए हमारे पास किसी भी तरह का, जब हमारे पास और कोई रास्ता ना रह जाए, तो साहब हमें तब नॉन पैरामीट्रिक की तरफ जाना चाहिए, ठीक है? या फिर सिचुएशन ही ऐसी है कि नॉन पैरामीट्रिक ही होगा, जैसे काई स्क्वायर टेस्ट, वो तो सिचुएशन ही नॉन पैरामीट्रिक की है ना? तो जब तक हो सके पैरामीट्रिक टेस्ट करने की कोशिश करनी चाहिए, ठीक है? तो ये तो था आपके प्रश्न का उत्तर। आप नहीं पूछते प्रश्न तो मैं ही बना देता हूं आपकी तरफ से। आपका एक दूसरा प्रश्न भी हो सकता है यहाँ पर कि सर ये जो आपने लॉग ऑफ वेट ले लिया, ये तो रिजल्ट्स को इंपैक्ट नहीं करेगा। एक्चुअल में तो ये कमाल की बात ये है कि आप चाहे इसका टी टेस्ट करो चाहे इसका टी टेस्ट करो, वैल्यूज सेम आएंगी, सेम वैल्यू ऑफ टी। ओके, और कुछ भी नहीं बदलेगा, डोंट वरी। ओके, नाउ तो अब मेरे पास आई हैव नाउ चेंज्ड, I have converted weight into log of weight. Okay, and now I would like to see the distribution of this particular variable. So let's check that. And now we know how to test the normality. We will go to analyze, we will go to descriptives, we will go to explore, we will remove this weight from here and take log of weight here, go to plots and say histogram and normality plots, say continue, say okay, and see the results. आपने एक चीज देखे हैं, एक देखिए आप, मैंने जब वेट का डिस्क्रिप्टिव किया था तो ये आया था स्क्यूनेस एंड कुर्टोसिस, देख रहे हैं आप, स्क्यूनेस एंड कुर्टोसिस 0.254 एंड 0.503। जब मैंने लॉग ऑफ वेट कर दिया तो स्क्यूनेस कुर्टोसिस क्या आया, सेम 0.254 एंड 0.503। इसका मतलब डिस्ट्रीब्यूशन में फर्क नहीं पड़ता है, डोंट वरी। बट सी, अब हमें क्यू प्लॉट देखने की जरूरत ही नहीं है, क्योंकि बोथ p values are greater than 0.05, means null hypothesis accepted. It means weight distribution of weight is normal. ठीक है, तो आप ऐसे भी कर सकते हैं, ठीक है। अब ये आपके ऊपर है, आप कैसे करना चाहें। So this is how we actually check the normal distribution. Okay. और वैसे भी अगर आप इसका हिस्टोग्राम देखें तो हिस्टोग्राम बेल शेप का दिखता तो है, देखिए, है ना। देखिए इस वेट का हिस्टोग्राम है ये, है ना। अगर हम देखें ध्यान से तो देखिए ऐसा लगता नहीं है कि ये बेल लग रहा है, बेल ऐसा लग रहा है ना। तो देखो परफेक्ट नहीं मिलेगा कभी भी, कहीं आप सोच रहे हैं जब हम खुद ही परफेक्ट नहीं है तो हम डेटा से कैसे एक्सपेक्ट कर सकते हैं परफेक्ट होना, है ना। तो इट्स वेरी सिंपल। सो बस उसके आसपास ही हो नॉर्मल के, सो इट्स नॉर्मल डिस्ट्रीब्यूशन। और देखिए वो टेस्ट ने बता भी दिया कि हाँ साहब नॉर्मली डिस्ट्रीब्यूटेड है, डोंट वरी। इसका मतलब ये है कि हम पैरामीट्रिक टेस्ट अप्लाई कर सकते हैं, पैरामीट्रिक टेस्ट अप्लाई कर सकते हैं, ठीक है, यानी कि टी टेस्ट अनोवा इस पर लगा सकते हैं। अच्छा अब और सुनिए, वैसे तो ये होता है कि जब आप वेट का डिस्ट्रीब्यूशन देख रहे हैं तो आपको दोनों पॉपुलेशन का डिस्ट्रीब्यूशन देखना पड़ेगा, यानी कि ऐसे नहीं करना होगा, आपको ऐसे करना होगा, मेल्स के वेट का डिस्ट्रीब्यूशन देखना होगा, फीमेल्स के वेट का डिस्ट्रीब्यूशन देखना होगा, ये अलग अलग से नॉर्मल डिस्ट्रीब्यूशन आना चाहिए, ठीक है। लेकिन ये ज्यादातर सोशल साइंसेस में करते नहीं है, ठीक है, सोशल साइंसेस में ऐसा करते नहीं है, साइंस में ज्यादा करते हैं, टेक्निकल साइंस में। ओके, वो इसलिए क्योंकि यू नो ये नॉर्मल डिस्ट्रीब्यूशन आता नहीं है और परेशानी हो जाती है लोगों को, और फिर लोगों ने इस पर ज्यादा प्रैक्टिस कर नहीं रहे। एक्चुअल में पॉपुलेशंस का नॉर्मल डिस्ट्रीब्यूशन होना चाहिए। तो पॉपुलेशंस मींस मेल पॉपुलेशन, फीमेल पॉपुलेशन, तो दोनों सैंपल्स का ही नॉर्मल डिस्ट्रीब्यूशन होना चाहिए। ये तो ये होता है असली, ऐसे ही करना होता है, ठीक है। इन केस इफ यू वांट टू राइट अ वेरी गुड रिसर्च पेपर, सो देन यू शुड डू दिस इन दिस वे, ओके। चलिए अब आगे बढ़ते हैं। नाउ सिंस वी आर डूइंग नॉन पैरामीट्रिक टेस्ट वर्कशॉप, तो वी विल बी एज्यूमिंग, क्या एज्यूम करेंगे हम, कि साहब ये नॉर्मल डिस्ट्रीब्यूशन नहीं है, तभी तो हम क्या कर पाएंगे, सारे नॉन पैरामीट्रिक टेस्ट कर पाएंगे। ओके, सो फॉर टी टेस्ट, द सब्स्टिट्यूट of the t-test or the counterpart of the t-test in non-parametric is what we have done yesterday. And what was that? Mann, Whitney, u-test, ये हमने कल किया था, है ना। करके देखते हैं अब। और analyze, go to non-parametric test, go to independent samples Okay, go to this customize analysis. Okay, fields, weight, इसको reset कर दे दोबारा से, weight को यहाँ लेकर के जाए. Okay, settings में yesterday we actually used automatic version here, but now let's do it customize. Customize, and then which test I should check on? Man Whitney U test, 2 samples, and then press run. Oh, हमने field तो लिया ही नहीं. So let's take weight. Where is the weight? Weight is there. And where the group here? Gender. Okay. And Man Whitney U test run. Okay. So wait, it's taking time. Now it has completed. So it is. So what was the null hypothesis? The null hypothesis was the distribution of weight is same across categories of gender. And the test was independent samples Man Whitney U test. And the significance is 0.783. So the p-value means significance is nothing but the p-value. So p is greater than 0.05 here. And now 0.7 is greater than 0.7 is greater than 0.05. So what would be the result? Null hypothesis accepted. So what was the null hypothesis? What was the null hypothesis? Gender is not related. Okay. And this is another way of writing the same thing. Distribution of weight is same across categories of gender. Related to weight. भाई weight से related relation कोई नहीं है. Distribution same है. यानी कि weight कोई difference नहीं करता male female में. सीधा distribute करता है अपने आप को. So that has been accepted. Okay. So this is Man Whitney U test. Chalo, let's take the another example here. Now another case, not example, another case. So what would be the another case? So I have taken 2 independent samples. So let's take the one sample. Let's take the one sample. One sample. So yesterday we worked on one sample and we actually spent a lot of time on one sample. So what is that one sample? When there is no categories. So what does that mean? No categories. It means that the entire sample is taken as one. Is taken as one. So no categories. So you will be comparing with some claimed parameter. कुछ claimed number या claimed parameter से आप उसे compare करेंगे. Okay. So the example was ghee factory. Okay. As you want to see whether the weight of each packet is somewhere around 950 grams or not. If it is far lesser or higher, then that is going to harm my reputation and my profits as well. So in the same case, ambulance case, yesterday we took the example. Ambulance says within 8 minutes I reach, go anywhere and get your medical emergency. Okay. We will be reaching within 8 minutes. So in that case also, I need to compare the results with 8 minutes. Okay. Here, in this situation, with how can I actually compare with the one parameter? No one has claimed anything. So let's assume something. So let's assume that this particular this particular data has come from, say, come from a particular trainer. Okay, किसी ट्रेनर के से ये डेटा हमारे पास आया है. Okay, and the trainer is claiming that the mean weight of people is 80 kg. ट्रेनर कहता है कि मेरे पास जो लोग आते हैं, जितने भी लोग आते हैं, उनका मीन वेट 80 होता है. So we took a sample of 90 people. ये जो सैंपल देख रहे हैं आप, ये वाला, we took a sample of 90 people and tried to find, and randomly selected, simple random sampling. Okay, we took a sample of 90 people and took their weight just to see whether these people actually have 90 kg as mean weight, or so how can we do that? Okay, how can we test this particular hypothesis? So the first challenge is how to make a hypothesis. Hypothesis क्या बनेगा इसका? क्योंकि claimed amount है, claimed number है 80 kg. Okay, so इसका null hypothesis क्या बनेगा? No action required, nothing is to be tested. Okay, there is no, change in anything, and whatever is being claimed by the trainer is true. Okay, so the null hypothesis is the mean weight of the people is 80 kg. So this is something which I need to hypothesize. The mean weight of the people is 80 kg. You got my point? So this is actually, होता क्या है कि लोग ये समझते हैं कि null hypothesis means no. हमेशा no लिख दीजिए. No ऐसा नहीं होता है. ध्यान रखेंगे आप इस बात का. जैसा कि अभी हमने नॉर्मल डिस्ट्रीब्यूशन में देखा था, तब भी अगर हम अपनी पुरानी नॉलेज से जाते तो उसका null hypothesis क्या बनाते? Data is not normal. No. You need to go by the definition, not by your habit. है ना? So definition is everything is normal, nothing is changed, no action required. So nothing is changed means whatever is being claimed is claimed. So null hypothesis is the mean weight is 80 kg. This is being claimed. Okay, wonderful. So now let's work on this particular data, that is weight, and see and test this particular hypothesis. फिर इस hypothesis को हम क्या करते हैं? Test करेंगे and find out whether this hypothesis is true, means accepted, or false, means rejected. If this hypothesis is true, it means mean weight is 80 kg. If this hypothesis is false, then mean weight is not 80 kg. Then either it is more than 80 kg or it is less than 80 kg. But what it is, that the value, the analysis will tell us. That the analysis will tell us. So let's do that. Let's go to analyze, compare means, and see one sample t-test. Okay. And here, what is the test variable? Weight. And see here, what is written? Test value. इस टेस्ट वैल्यू को किससे कंपेयर कर रहे हो? Okay. Now, so here the test value is, just a minute. Yeah. So here the test value is 80 kg. Okay. And the test value is 80 kg. And in case if I go to options, I can only check one thing. And I should always check one thing, that is in which particular percentage value I am checking my confidence level. And my confidence level is 95%, which is always by default. And you don't have to do anything else other than just this test value. Okay. And then press OK. Now, here. So what is the mean which came? Just see the mean, 66 kg. Okay. What is being claimed? What is being claimed? 80 kg. Okay. The difference is very high. Now this difference, whether this difference is a significant difference or not, that will be told by what? Significance, p-value. And what is p-value? 0.000, which is less than 0.05. देख रहे हैं आप? P-value is less than 0.05, which means null hypothesis rejected. What was the null hypothesis? The weight is 80 kg. Mean weight is 80 kg. But this null hypothesis gets rejected. Now, what does that mean? It means that weight is not 80 kg. Mean weight is not 80 kg. Then what is the mean weight? 66.12. 66.12. Okay. So this you need to be very careful of. So this is how you actually test the one sample. One sample. Now, this one sample of weight has to be normally distributed. Only then you can apply one sample t-test. What if weight is not normally distributed? What if weight is not normally distributed? We cannot go for one sample t-test. Then where we can go? Here is the answer. One sample, if it is, if it is a non-parametric test, then we'll go for Wilcoxon signed rank test. Wilcoxon signed rank test, if it's a continuous variable. Assumptions are not met. Okay. So how to do that? Just go to analyze, go to non-parametric test and see. Here it is written, one sample. Okay. Customize analysis, fields, all the fields are there. No? Reset. Why all the fields have come here? Go back. Okay. Now in the test field, put weight. Okay. And go to settings. And in settings, which particular test value? Customize setting. So which particular test that you need to do? Compare median to hypothesized. Wilcoxon signed rank test. This much. This one, sorry. So in this particular test, which is Wilcoxon signed rank test, what is the hypothesized median? It's not mean, because mean is not reliable when it is not normally distributed. Okay. So then we'll go by median. So hypothesized median is 80 kg. Okay. Press run. Okay, so this is the result of one sample Wilcoxon signed rank test. Now see, what is the hypothesis? The median of weight equals 80. However, in case of parametric test, the mean of weight. Okay, because mean is not reliable for abnormal data, which is not normal data. So in that case, we go by median only. So the median of weight equals 80. So this is the null hypothesis. So one sample Wilcoxon signed rank test is being applied. Significance is 0.000. So p-value is less than 0.05. Null hypothesis rejected. Null hypothesis rejected means the median of weight is 80 is rejected. So here reject the null hypothesis. It's written as well. यहाँ पे लिखा भी हुआ है. Reject the null hypothesis. This one. Any doubt? As of now? Okay. So this is how we are actually converting one sample parametric test to one sample non-parametric test. Okay, because the data is not normally distributed. चलिए आगे बढ़ते हैं. So here, if you look at one sample, and that too when the data is non-parametric, means the data is subjective, when the variable is categorical, then what kind of distribution that we should look for? For example, just see here in this case, here if you see, I want to see whether the randomness. Okay, these are the see what happens that when you want to test the randomness of a particular variable, whether this particular variable is being randomly selected or not, then this is called one sample non-parametric test. Whether male and female are being randomly selected, means no biasness is there, then you should also go for chi-square test or binomial test for randomness. Okay, however, mostly people do not do this and assume that this is randomly selected and unbiased. So whatever the the observations that has been that has been taken here is randomly selected. So how you can check that? Go to analyze, okay, and go to non-parametric test and go to one sample. But here in one sample, instead of weight, take gender. Okay, and go to settings, and its customized level, just see test sequence for randomness. देख रहे हैं आप? So in case if I do that, okay, because I am not going to compare it with any hypothesized value. Okay, run. So what it says, what is the null hypothesis? The sequence of values defined by gender is equal to male and female is random. So this is the null hypothesis. Don't worry, everything has been selected randomly. Okay, so if I want to see the randomness test, just see it's a one sample runs test and the p-value is 0.639, which is greater than 0.05, which means null hypothesis Null hypothesis? Yes, you are thinking right. Accepted. What does that mean? It means, yes, the sequence is random. Okay, so retain the null hypothesis. So when the sequence is random, it does not follow any trend. Okay, it means it is good to go for analysis. Good to go for analysis. However, people do not use it, but it's very important sometimes. Very important. So this is one sample test of categorical data. हम randomness की बात करते हैं. We test the randomness. Okay. Very good. Now let's talk about the now one sample is done. Okay, one sample is done, and one sample non-metric is also done. One sample continuous done. One sample without assumptions is done. Two independent metric is done. Two independent non-parametric done. Now this non-metric is there. Non-metric is there, two independent. This, so it's a bit lengthy. So let's first do it. Paired sample. Let's first do paired sample. Before paired sample, let's first do Kruskal-Wallis. Ye jana acha. More than two independent sample. So one sample, two independent sample, more than two independent sample. That makes sense. Okay. So we have done one sample. We have done two independent samples. Now let's do more than two independent samples. Okay. Now how you are going to differentiate? Yes. So more than two independent samples. Now what does that mean? It means that here we have two independent samples, male and female. So when you have two variables, variable 1 and variable 2, okay, variable 1 is categorical with more than two categories. More than two independent sample means more than two categories, and variable 2 is continuous. So which test that we should go for? F test. ANOVA. Okay, which you must have done ANOVA. Okay. Now, what is the counterpart of ANOVA? Kruskal-Wallis test. Have you done ANOVA or not? Have you done ANOVA or not? Anyone? You have done ANOVA? Anyone? Have you done the ANOVA test? F test? Parametric?
Yes,
Yes,
sir.
yes.
Okay. Fine. That's great. Let's not waste time there. So let's do the non-parametric counterpart of ANOVA, and that is Kruskal-Wallis. Now here in Kruskal-Wallis, what is the case here? How can you make a case out of this particular data for Kruskal-Wallis test or for ANOVA for that matter? How will you make the case? Now, when I want to test the relationship between profession and weight, when I want to test the relationship between profession and calorie intake, okay, Now, how can I do that? Just see. Now, what does that mean? Whether profession and weight are related or not. That is whether a particular profession influences the weight of a person. क्या ऐसा है कि गवर्नमेंट एम्प्लॉई थोड़े ज्यादा ओवरवेट होते हैं और बिजनेसमैन और भी ज्यादा ओवरवेट होते हैं और प्रोफेशनल्स तो बड़े फिट रहते हैं? मुझे लगता है कि आदमी का क्या प्रोफेशन है, क्या ऑक्यूपेशन है, उसके हिसाब से उसके वेट पर फर्क तो पड़ता है. बट देयर आर पीपल हु सेड कि नो नो, it does not matter. Okay, so we took a data of 90 people. Okay, a random sample, simple random sample from a particular population. Okay, from a particular population, and to find out whether the profession influences the weight or not. है ना? So profession which has more than 2 categories, categorical variable, and weight is continuous. So which test I am going to apply? ANOVA, F test. Okay. But if weight is not normally distributed, assumptions are not being met, then I will go for Kruskal-Wallis test. ठीक है, चलिए करते हैं Kruskal-Wallis test. We'll go to analyze. So what would be the hypothesis? Null hypothesis. Because before doing the test, it's important for us to formulate the hypothesis. Because what we are doing, we are testing the hypothesis. No? What we are doing, we are testing the hypothesis. So, what would be the hypothesis? Hypothesis will be null hypothesis. Huh? We are creating null hypothesis. That the influence of profession is not there on weight. ठीक है, इसको दूसरे तरीके से भी लिख सकते हैं हम. कैसे? Profession does not influence weight. ठीक है, हम ऐसे भी लिख सकते हैं the distribution, एक और तरीका, distribution of weight is same across profession. So this is how we create the null hypothesis. So null hypothesis can be created in various ways. Okay, now, so null hypothesis created, no influence. Okay, now let's go to analyze. Okay, go to non-parametric. Okay, if it is parametric, then we will go to compare means, and in compare means there is something called one-way ANOVA, and you can write the ANOVA here. You can write the variables. Variable is weight and the factor is what? Profession. And you can actually do the post hoc analysis as well. Turkeys or turkeys B, whatever. So you can also do post hoc analysis. इसको cancel कर देते हैं. However, this post hoc analysis is not available in non-parametric test. Okay. You need to do it separately by just choosing two categories at one time. Okay, if you want to do the post hoc test in non-parametric data. Okay, so we'll go to analyze, we'll go to non-parametric test and independent samples, because this independent sample may be two or more than two, and these more than two samples are independent to each other. Means professions are independent to each other, So reset. So customize analysis, fields. In fields, which is the test field? Weight. And which is the groups field? Profession. Any doubt? And then go to settings. In settings, you are asking SPSS to automatically choose the test based on the data. This is the data, weight and profession, and I'm not customizing the test. Where is the customizing? Where is the Kruskal-Wallis test? This one. Okay. So in Kruskal-Wallis, one-way ANOVA, okay, K samples. So instead of checking this box, I would say, no, I don't want to check this box as Kruskal-Wallis. I want the SPSS to decide which test SPSS is going to apply. Okay, run. Now, this is the result of Kruskal-Wallis test. Now, what was the null hypothesis? The distribution of weight is same across categories of profession. So the distribution of weight is same across categories of profession. Okay. So what does that mean? It means that profession does not influence weight. So which test SPSS applied on its own? It's Kruskal-Wallis test. The same test which we did not check on, and we said, no, let the SPSS decide. So SPSS actually decided the same. Okay. And what is the significance level? 0.063. So P value is 0.063, which is greater than 0.05. So null hypothesis 0.06 is greater than 0.05. Let me fix charger, just a minute. Otherwise it will get switched off. So 0.063 is greater than 0.05. So what does that mean? Null hypothesis P high, null fly, accepted. So this is accepted. So it is saying retain the null hypothesis. तो सब कुछ तो बता दिया SPSS ने आपको, कुछ बचा ही नहीं. Okay. So it means, so what does that mean? Null hypothesis accepted means what? Means profession does not influence what? ये आप कोई भी प्रोफेशन कर लीजिए, उसका आपके वेट से रिलेशन नहीं है. वेट तो आपका अपना है, आप ही डिसाइड करेंगे. अभी बहानेबाजी बंद कर दीजिए आप, क्योंकि मेरा काम ऐसा है ना, इसलिए मेरा वजन बढ़ जाता है, ऐसे बोलते हैं. चलिए आगे बढ़ते हैं. एनी डाउट एज ऑफ नाउ? No. Hmm. अब हम बात करते हैं, ये देखिए, 2 इंडिपेंडेंट सैंपल, ठीक है, जहां पर अब हम ये हो गया 2 इंडिपेंडेंट सैंपल हो गया, मोर देन 2 हो गया, 2 इंडिपेंडेंट हो गया। अब बात करते हैं पेयर्ड सैंपल की। ओके, ये हर जगह एक जगह काई स्क्वायर लिखा हुआ है, ये काई स्क्वायर का मैं केस ही अलग से उठाऊंगा, ठीक है, आप लोगों के लिए, क्योंकि इस केस को हम एक ही बारी में उठाएंगे, और 2 इंडिपेंडेंट, 1 सैंपल, पेयर्ड सैंपल, मोर देन 1, ये सब एक ही बारी में हो जाएगा। इसलिए हम काई स्क्वायर को अलग से उठाएंगे। ओके, और अब नाउ लेट्स टेक व्हाट, पेयर्ड सैंपल। Now what is paired sample? Related sample means observation before and observation after. ऐसे ना, before and after. Okay, let's see. I hope that you all have been doing, or you get more time to do it with me. Okay, chaliye, just see. So here, paired sample. Now, when I talk about paired sample, let's talk about metric paired sample first. So what is metric paired sample? Metric paired sample means continuous paired sample. So a sample which is, a value which is taken before and after. So weight after training and weight before training. This is before and this is after. So both are continuous. By whatever the unit that you have applied before, the same unit you need to apply after as well. Okay. Otherwise, how will you compare? You cannot. So since it is continuous, then it should also be continuous. So both are continuous. Now, I would like to see whether the training has some impact on the weight of the people, means whether training was effective or not. Okay, so it's important. So in that case, I will use, so I have one sample, okay, but the observations are taken twice. So that is why we sometimes call it paired sample, sometimes we call it dependent sample, sometimes we call it related samples. Okay, is tarah se. So in this case, which particular test I should go for? Paired sample t-test. Paired sample t-test. Okay, but in case of non-parametric test, which particular test I should go for? Wilcoxon matched pairs ranked test or sign test. So we discussed it yesterday as well, that if I compare Wilcoxon matched pair ranked test with sign test, it's more robust and better. However, I'll show you where the sign test is there in the non-parametric tests. So both are there in SPSS, Wilcoxon matched pair and sign test as well. So paired sample t-test you must have done. Okay. So let's do direct Wilcoxon signed test. So go to analyze. So first, what is the null hypothesis? The distribution of marks, the distribution of weight before and after is same. This is the distribution of weight before and after is same. This is one way of writing the null hypothesis. The second way is there is no effect of training on weight. Okay. And there's a third way as well. The mean weight before and after training, okay? The mean weight is same before and after training. Okay. So this is the null hypothesis you can create, you can formulate. So there's so many ways, but all actually have the same meaning. Okay. Now go to analyze, go to non-parametric test and see there is something called related samples. Customize analysis, go to fields and transfer two fields here, which you want to see here. It is in select only two test fields to run two related sample test. Okay. So what are those two fields? Weight and weight after training. Okay. And then go to settings. In case if I go to customize test, then here is the test. Wilcoxon matched pair signed rank, 2 samples. The second is sign test, 2 samples. So both, in case if you want the results of both will come. If you want the result of one will come. Okay. So, but if you want that the automatically choose the test based on the data, SPSS can do that as well. Okay, but this time we are asking SPSS to use Wilcoxon matched paired signed rank test. So run the test. Here is the results of the test. So what was the null hypothesis first? The null hypothesis is the mean weight before and after training is same. ठीक है, मीन्स डिफरेंस आया ही नहीं मीन वेट में, यानी कि लोगों के वेट में फर्क पड़ा ही नहीं ट्रेनिंग से. ओके, नाउ सो व्हाट इज द नल हाइपोथेसिस दैट SPSS has created? The median of differences. Okay, however we call it as mean because we create the hypothesis as mean, but when we are using non-parametric test, mean cannot be used, it's not reliable, so we actually use median. Okay, so this is the only difference that you need to understand. Okay, so it says the median of difference between weight and weight after training equals 0, means कोई difference ही नहीं है साहब. Okay, कोई difference ही नहीं है median weight में या mean weight में. Okay, before and after. So here what test that they have applied? Related samples Wilcoxon signed rank test. Okay, and the null hypothesis gets rejected. कैसे? Because the p-value is equal to 0.000, which is less than 0.05. If p-value is less than 0.05, it means that null hypothesis rejected. Null hypothesis rejected. So what was the null hypothesis? Mean weight before and after training is same. No. Not at all. The mean weight is different. So now you can calculate the mean weight or the median weight and find out for before and after. It's very simple. Okay. And how can you calculate mean before and after? How can you calculate the mean before and after? It's very simple. Here, go to analyze, go to descriptive, take weight here and take weight after training here. You go to options. So calculate the mean weight. Okay. And find out. Continue. Okay. So here is the mean. So mean weight before training was 66.121 and mean weight after training is 63.13, which means that there is a difference of 3 kg. Okay. And the difference is significant. Okay, difference is significant. So this is what you need to understand. So that is why difference is significant. That is why p-value is less than 0.05. Okay. So this is paired sample. Paired means related sample. Samples. Okay. क्या नाम था टेस्ट का? Wilcoxon sign rank test. I hope आपको चीजें समझ में आ गई होंगी. ठीक है. So let's take a break of around 10-15 minutes, 15 minutes. So we'll meet at 16:45.
Okay, sir.
To
Okay.
do the further analysis. 6:45 we'll meet. Any question? Oh, in case if you have any question, we'll take it after the break. Thank you.
Participants don't leave the meeting. Will join in 15 minutes.
Participants, please fill the feedback form. The link is given in the chat box.
Yes. I hope all are in. All have come.
Yes,
sir.
Great, wonderful. So let's start with where we left. So let me first share my screen. Okay. And yes. So we have done what? We have done the paired sample, related samples, Wilcoxon sign rank test as well. So before moving further, any doubt? Any question? No? Okay. So let's start with the next part. So the next part is, let's now talk about chi-square test. Means when two independent samples are there, okay, and in that two independent sample, both the samples are what? Both the samples are, both the populations, not populations even, variables are categorical. So when one is categorical with any number of categories, be it 2 or be it more than 2, whatever, okay, and the another variable is also categorical, and we would like to see the relationship between these two variables, then we go for, so we do not have any other, parametric test for that, because no parametric test will be applied to categorical data. It's very simple. So we will go for chi-square test. Okay. So chi-square, you all know how to chi-square, to calculate the summation of observed frequency minus the expected frequency whole square divided by expected frequency. So this is the formula of chi-square. So what is this observed frequency? What is this expected frequency? When we do not have anything, no mean cannot be calculated, median cannot be calculated, no standard deviation, nothing. So no parameters are there in categorical variables. So what is left is just count. That is the frequency. So what we do actually in chi-square test, we actually create a cross tabulation. Okay. So what we create? Cross tabulation. Now what is cross tabulation actually? Cross tabulation is nothing. You must have actually done the pivot table in Excel. So it's same as cross tabulation. When you take a categorical variable in rows, okay, in pivot table, and a categorical variable in columns, so that actually creates what? A cross tabulation. It's very simple. So cross tabulation is nothing but frequency distribution. It's frequency distribution of two categorical variables. Very simple. So this is called cross tabulation. Means what is the frequency? For example, in case if I have one variable, say gender. So how can I create the frequency table of gender? So gender frequency table is male and female, and count. Male say 45, female say 40, say 35, whatever. So this is called frequency table. This is called frequency table. Okay. Then what is cross tabulation? When we take two categorical variables together. अच्छा, ये कैसे हो सकता है? हो सकता है. How many males are there? For example, here, if gender is there, and say smoking status. So some are male, some are females, है ना? So and some smokes and some do not. है ना? Yes, no, male, female, इस तरह से. So now in case if I want to create a frequency table, so here, say here is gender, okay, down, and here is smoking status. This, it's like that. So male, female, okay, it's like that. Smoking, yes. Smoking, no. So how many males who smoke? Yes, say 23. No, say 44. Female, yes, 115. No, say 47. So now in a particular table, when we actually give frequencies, okay, of two categorical variables, and that to relate it to each other. Okay, so here is total of males. So this is the total of male, 7, 6. What is the total of females? 62. What is the total of smokers? Yes, 38. What is the total of non-smokers? 19. So this is how you actually create the total. Okay, so and if you actually take the total here, the grand total, you take the row total or the column total, it will be same. What is this? 9, 129. So this is the grand total. So this is called cross tabulation. It's called cross tabulation. And in chi-square test, we make use of this cross tabulation. Okay, very important to understand. Okay, so now even if you want to test, now this corona actually is corona vaccine, you know? So people actually have a doubt whether this vaccine works or not. So how can you test whether the vaccine works or not? We can use chi-square test. How? So we'll collect the data of people, observation number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, then we'll ask a variable. Vaccinated? Yes, no, no, yes, yes, no, yes, 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 no, no, no. And now attacked by virus. Yes, no, yes, 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 no, 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 yes, no. So we would like to see, is there any relationship between vaccinated person and the incidence of attack? Means attack, that is the exposure to the virus, and vaccination are linked or not? Is there a relationship between vaccination rate or attacking or getting the infection, corona infection? So in that case, what is the best way? Means they are related or not related? We'll go for chi-square test. Why? Because I would like to see the relationship between these two variables, and both the variables, variable 1 and variable 2, both are categorical variable. If one is categorical, second is categorical, and I want to see the relationship, I'll go for chi-square test. So what the SPSS will do? SPSS first create a cross tabulation. पहले इनका क्रॉस टेबुलेशन बनाएगा, ठीक है। उसके बाद देखेगा कि फिर उसके बाद काई स्क्वायर की वैल्यू निकलेगा, काई स्क्वायर वैल्यू। उसके बाद देन इट विल गिव यू द p वैल्यू। If p is high, null fly. What is the null? There is no influence of vaccination on the attack, virus attack. Simple. Means no relationship between vaccination and attack. ये सब ऐसी बकवास कर रहे हैं फालतू में, सबने अपने आप को एक नीडल चुभवा ली, कुछ फायदा नहीं हो, ऐसा कह रहे हैं. This is null hypothesis. And okay, and what is alternate hypothesis? No, इसका इफेक्ट होता है. तो if p, so let's take null hypothesis. So if p, and we will calculate the p value. If p is high, then null fly, means null accepted. If p is less than 0.05, then no, it is rejected. It means no, वैक्सीनेशन का फर्क तो पड़ा है भाई. जिन लोगों को वैक्सीन लगी है उनके ऊपर अटैक कम हुआ है. ओके, तो इस तरह से हम इसलिए मेडिकल में सबसे ज्यादा यूज होता है काई स्क्वायर टेस्ट. किसी भी एमडी करने वाले डॉक्टर से आप पूछोगे कि आपने काई स्क्वायर टेस्ट किया है, तो बोलेगा हाँ हाँ मैंने जरूर किया है, क्योंकि वो जरूर करते हैं ये टेस्ट. क्योंकि वो देखना चाहते हैं कि कहीं ऐसा तो नहीं है कि हमारी दवाई मेडिसिन से इंसिडेंस बढ़ रहा है या फिर वैसे इंसिडेंस बढ़ रहे हैं या घट रहे हैं, है ना. तो ये आपस में रिलेटेड है या नहीं है. कहीं ऐसा तो नहीं है कि सब कुछ बाय चांस हो रहा है और हम खुश हो रहे हैं कि हमारी दवाई से ठीक हो रहा है, जैसे होम्योपैथिक वाले होते हैं. वो कहते हैं कि हाँ ठीक हो जाओगे 10 दिन लगेंगे. अरे 10 दिन में 5 दिन में तो आदमी वैसे ही ठीक हो जाता है बिना दवाई के. वो समझते हैं हमारी दवाई से ठीक हो रहा है. लोग भी सोचते हैं हम ठीक हो गए मोबाइल से, होता कोई नहीं. आई एम जस्ट किडिंग. ओके, चलिए आगे बढ़ते हैं. तो हम करते हैं अब काई स्क्वायर टेस्ट और देखते हैं कि क्या रिजल्ट्स आते हैं. Yes. So in here, if you see the cases, what is the case here? Which is that case where you can apply chi-square test? Which is that case? Here, see. I would like to see whether profession is related to smoking. ऐसा है कि एक पर्टिकुलर प्रोफेशन के लोग स्मोकिंग करते हैं. ये गवर्नमेंट एम्प्लॉय बहुत स्मोकिंग करते हैं या प्राइवेट एम्प्लॉय बहुत करते हैं, या अपने ऑफिस से बाहर आते हैं एक सिगरेट फूकी और गए अंदर, ऐसे करते हैं. तो या ये बिजनेसमैन जो है ये अपनी बिजनेस करते हैं तब ये स्मोक बहुत करते हैं. तो व्हाटएवर, like I believe that there is some problem. So private employees are there and the government employees are there. So there are so many employees: private, government, business, professionals, homemakers. I would like to see the relationship between these two variables. So whether profession affects their smoking status or not. So now variable 1, this is variable 2. Now this variable is categorical. This variable is also categorical. So which particular test I am going to apply? Simple chi-square test. Chi-square test. Okay. And before applying the chi-square test, I need to formulate a hypothesis. What will be the hypothesis? What will be the hypothesis? Null hypothesis? Yes, you are right. What? That there is no relationship. There is no relationship. अच्छा, एक चीज मैं आपको बताता हूं, ध्यान रखिएगा. whenever we talk about any other test other than chi-square, we call relationship. But in case of chi-square, we do not call it as relationship. We call it as association. Association. So there is no significant association between profession and smoking. अगर आपका क्वेश्चन ये है कि सर एसोसिएशन क्यों कहते हैं, तो कहते हैं भाई एसोसिएशन ज्यादा अच्छा लगता है, रिलेशनशिप एक्चुअली में वो कंटिन्यूअस वेरिएबल के लिए यूज कर रहे हैं स्टैटिस्टिशियन, अब उनकी मर्जी थी तो उन्होंने एसोसिएशन कहने लगे, उनको लगता है कि एसोसिएशन वर्ड ज्यादा अप्रोप्रिएट होता है व्हेन बोथ द वेरिएबल्स आर कैटेगोरिकल. सो काई स्क्वायर का जब भी हाइपोथेसिस बनाएंगे ना तो रिलेशनशिप मत बोलना, एसोसिएशन बोलना. Okay. So we have formulated the hypothesis. We know which particular test is to be applied. So let's do that. Let's start doing the test and see what results will come. Okay. So let's start. Let's go to. So let's go to analyze. Here, instead of going to non-parametric test, which we can go to, but we will not, because here, if we go to descriptives, just see here. So there is a catch here, no? So analyze, go to descriptive statistics, and then go to frequencies, no, descriptives, no, explore, no, cross tab, yes. This is the cross tabulation that I want, cross tabulation that I want, okay. So I would like to see the relationship between what? The profession and smoking status, okay. So profession is on rows and smoking status, smoking habit on column. Now you may have a question कि सर उसको रोज में क्यों लिया, उसको कॉलम में क्यों नहीं लिया? Yes, आप किसी को किसी में भी ले सकते हैं, है ना. आप स्मोकिंग हैबिट को रोज में ले सकते हैं, प्रोफेशन को कॉलम में ले सकते हैं, कोई प्रॉब्लम नहीं है. रिजल्ट ऑल्सो विल नॉट चेंज, कुछ भी नहीं बदलेगा, ठीक है, सब कुछ सेम रहेगा. मगर रीति रिवाज जो होते हैं ना, ये राहुल जी प्लीज म्यूट योरसेल्फ. Okay, thank you so much. So now you may have a question ki why should we take, why can't we take? We can. Whether it will affect the result? No, it will not. But there are some conventions. What is the convention? Convention is, because when the cross tabulation will be formed, that cross tabulation will be easier to be read. Okay. Easier to be understood. So that is why that convention. Otherwise, no effect. So the convention says, always take dependent variable into columns. Now, what do you mean by dependent variable here? By profession से smoking decide होता है, ना कि smoking से profession. आप उल्टा वैसे बोल सकते हैं, मगर मैं ये देखना चाहता हूँ क्या profession से smoking पर असर आता है, या फिर ऐसा तो नहीं है कि ऐसा तो हो नहीं सकता कि नहीं मैं स्मोक करता हूं ना इसलिए मैं बिजनेस करने लग जाता हूं, मैं स्मोक करता हूं ना इसलिए चलो मैं गवर्नमेंट एम्प्लॉय बन जाता हूं. ऐसा कोई नहीं करता. लेकिन ऐसा जरूर देखा गया है कि हाँ किसी चीज का किसी पर इम्पैक्ट पड़ता है ना. सो दैट इज व्हाई हियर इन अ सेंस लॉजिकली स्मोकिंग हैबिट इज डिपेंडेंट ऑन द प्रोफेशन एंड वी वुड लाइक टू चेक दैट, है ना. सो एम आई टॉकिंग सेंस और नॉट? Again, so smoking habit may be dependent on profession, okay, and my null hypothesis is smoking habit is not depending upon profession. So this is my null hypothesis. I want to check that. Okay. So since smoking habit is the dependent, so that is why I have taken smoking habit in columns. और अगर आपको अभी भी मेरी बात समझ में नहीं आई तो घबराने की जरूरत नहीं है, किसी को किसी में भी ले लो, मींस स्मोकिंग हैबिट को रोज में ले लो, तब भी कुछ फर्क नहीं पड़ेगा, सेम रिजल्ट आएगा। चलिए एग्जैक्ट ये जो साथ वाला टैब है इसमें आपने कुछ नहीं करना, इसको एज इट इज रहने देना। कमिंग ऑन टू स्टैटिस्टिक्स, ये हमारे लिए सबसे इंपॉर्टेंट टैब है, इसको प्रेस करें। ठीक है, इसमें देखिए आप सबसे ऊपर लिखा है काई स्क्वायर, इस पे आप इसे चेक कर दे। ओके, बिकॉज वी वांट काई स्क्वायर। नाउ यू आल्सो हैव समथिंग कॉल्ड कंटिंजेंसी कोएफिशिएंट, phi and Cramer's V, lambda, है ना, and on the right side gamma, Somers D, Kendall's tau B, Kendall's tau C. Okay, so we'll see that later. Okay, so let's first only see chi-square. Okay, continue. Now we should also go to cells, and now I told you the formula of chi-square. The formula of chi-square is summation of observed frequency minus expected frequency whole square divided by expected frequency. This is summation of everything. This is summation of the entire result. Right? So this is the formula of chi-square. So observed frequency, what is observed frequency? वो जो हमने क्रॉस टेबुलेशन बनाया था, ठीक है ना, मेल फीमेल, मेल इतने थे, फीमेल इतने थे, ठीक है, दैट इज कॉल्ड ऑब्जर्व्ड फ्रीक्वेंसी, क्योंकि दिस इज द फ्रीक्वेंसी व्हिच हैज बीन ऑब्जर्व्ड, जो कि हमारे डेटा की है। ओके, बट देयर इज समथिंग कॉल्ड एक्सपेक्टेड फ्रीक्वेंसी एज वेल। एक्सपेक्टेड फ्रीक्वेंसी का मतलब होता है देयर इज अ फॉर्मूला ऑफ एक्चुअली कैलकुलेटिंग द एक्सपेक्टेड फ्रीक्वेंसी, है ना, रो टोटल इनटू कॉलम टोटल अपॉन ग्रैंड टोटल। तो इस तरह से हम एक्सपेक्टेड फ्रीक्वेंसी बनाते हैं। तो हम इसको अभी हमने कुछ नहीं करना, कुछ मैनुअल नहीं करना। हम किसको बोल रहे हैं? SPSS को कह रहे हैं कि साहब वैसे हम देखना नहीं चाहते, लेकिन फिर भी हम एक्सपेक्टेड फ्रीक्वेंसी पर चेक करते हैं। ठीक है, हम देखेंगे कि भाई क्या होता है, तो हम बोले हमें एक्सपेक्टेड फ्रीक्वेंसी। एक्सपेक्टेड फ्रीक्वेंसी देखनी भी चाहिए, क्यों देखनी चाहिए इसके बारे में आगे बात करने वाले हैं। अगर आप अपनी टेबल में ये भी देखना चाहते हैं कि भैया परसेंटेज वाइज क्या आ रहा है, देखिए जैसे यहाँ पर रो टोटल, तो देखिए परसेंटेज ऑफ रो, परसेंटेज ऑफ कॉलम, परसेंटेज ऑफ टोटल, रेजिडुअल भी देखना चाहते हैं, तो कुछ भी आप देखना चाहते कर सकते हैं, लेकिन अभी हम इसकी बात नहीं कर रहे और ये हमारे ज्यादा काम की भी है। ओके, सो लेट्स, सो व्हाट वी हैव डन, दोबारा से इसको मैं कैंसिल करता हूं, इसको भी कैंसिल करता हूं, हम भूल गए हम क्या क्या कर रहे थे। दोबारा से शुरू करते हैं, है ना। गो टू एनालाइज, go to descriptive, go to cross tabulation, and then take your profession into rows and your smoking habit into column. Go to statistics, press on tab, press on chi-square, continue, cells, and go to expect, take the expected count as well, and then press continue. In case if you really want to display the clustered bar chart, which also looks better in case if you are creating a project report, क्योंकि ये उसमें तो यूज होती नहीं है, थीसिस में काफी यूज होती है ना, प्रोजेक्ट रिपोर्ट एंड थीसिस, you actually use this clustered bar chart and all, है ना। So वो भी अच्छा लगता है, तो वो भी देखते हैं ना कैसा लगता है। स्टाइल फॉर्मेट असेंडिंग इट्स ओके, वो बाय डिफॉल्ट रहता है। स्टाइल आपने कुछ नहीं करना, कैंसिल कर दीजिए। बूट स्ट्रैपिंग तो हम यहाँ कर ही नहीं रहे, वो तो हम बाद में कभी करेंगे किसी और वर्कशॉप में, है ना। सो लेट्स प्रेस ओके, ओके, एंड हियर कम्स द रिजल्ट। वंडरफुल, क्या बात है। So this is the result of chi-square. So these are the number of observations, 90, there is no missing, there is 0 missing, so everything is good. It's good to go. Okay, wonderful. Now, so this is called, देखिए इसने लिखा भी है, profession, star, smoking habits, cross tabulation. ठीक है ना? Cross tabulation. So it means that it's a cross tabulation, not a beautiful cross tabulation. And what is this? It says that for business, the people who do business, there are 3 people who smoke, okay, and there are 8 people who do not smoke. So how many people are there who do business? 11 total. Then this is expected count, expected frequency. अगर relationship होता तो expected count ये आता 5.9 and 5.1, जबकि आ क्या रहा है 3 and 8. तो देखते हैं. तो expected count किसने निकाला, ये अभी हमने नहीं देखना. ओके, आगे बढ़ते हैं. Private employee, okay, private employee 14 count, and yes means private employee 14 smoke करते हैं और 8 smoke नहीं करते हैं, total 22. Government employee 10 smoke करते हैं, 11 smoke नहीं करते हैं, total कितने थे government employee? 21. Homemaker 8 smoke करते हैं, 10 नहीं करते हैं, कितने थे total? 18. Professional 13 स्मोक करते हैं, 5 स्मोक नहीं करते हैं, कितने थे टोटल? 18. ठीक है, सो ये टोटल आ गया. सो व्हाट इज द टोटल? 90. इनका टोटल कर लो तब भी 90 आएगा, इनका टोटल कर लो तब भी 90 आएगा. सो दिस इज द ब्यूटी ऑफ क्रॉस टैबुलेशन. ठीक है, आई होप आपको क्रॉस टैबुलेशन समझ में आ गया होगा, है ना? जो थीसिस करते हैं उनको क्रॉस टैबुलेशन जरूर लगाना है, रिसर्च पेपर वालों को नहीं. जिन्होंने थीसिस लिखना है उनको जरूर लगाना है. ओके, आगे बढ़ते हैं. नीचे वाली टेबल पे चलते हैं. ये देखिए, ये है काई स्क्वायर टेस्ट. देख रहे हैं आप? chi-square test. This is the value of chi-square. This is degree of freedom. You have nothing to do with that. वो इसलिए क्योंकि मैं आपको मैनुअल तो सिखा ही नहीं रहा. अगर मैं मैनुअल कैलकुलेशन सिखाता आपको, है ना, chi-square की, तो मैं आपको सब चीजें बताता. ये chi-square की वैल्यू है, क्रिटिकल वैल्यू से कैसे हम ऑब्जर्व वैल्यू को क्रिटिकल वैल्यू से कैसे कंपेयर करते हैं, फिर हाइपोथेसिस को कैसे टेस्ट करते हैं, वो मैं सब आपको सिखाता. लेकिन अब उसकी जरूरत नहीं है. क्यों? क्योंकि अब क्या आ गया है? SPSS. ठीक है, हम इसमें अब हमारी हेल्प ये करता है क्योंकि हमने बहुत पैसे दिए इसको खरीदने में. वो बात अलग है कि हमने नहीं दिए. ठीक है, अच्छा, पियर्सन काई स्क्वायर. सो दिस इज द वैल्यू, दिस इज द डिग्री फ्रीडम, दिस इज द एसिम्प्टोटिक सिग्निफिकेंस. ठीक है, सो दिस सिग्निफिकेंस इज एक्चुअली कॉल्ड p value. This is called p value. Okay. So what is the p value? 0.118, which is greater than 0.05. What does that mean? It means that p high null fly means null accepted. It means null true. And what was the null? No relationship. No relationship between profession and smoking. And there is no relationship. It has been proved here, accepted. And hence the result, khatam, ho gaya, done. Now in case if you want to see the cluster bar plot, this is the cluster bar plot. These are the business people who do, business people who smoke, don't smoke. Blue is the people who smoke, green is the number of people who do not smoke. In case if you really want to work on this graph can also be worked upon. इस ग्राफ के ऊपर भी काफी काम हो सकता है. ठीक है, अब देखिए, जैसे ही मैंने इस पे डबल क्लिक किया, इस पे सारी चीजें हो सकती है. पूरा का पूरा ग्राफ चेंज हो सकता है. इस पूरे ग्राफ पर आप काम कर सकते हैं। ठीक है साहब। तो ये भी एक नई चीज है, हम इसके ऊपर कभी बात करेंगे। तो ये था हमारा काई स्क्वायर टेस्ट फॉर 2 इंडिपेंडेंट सैंपल, है ना। ये तो 2 से भी ज्यादा थे। देखिए इसमें कितने सारे सैंपल थे, 2 तो ये थे यस और नो के 2 कैटेगरीज, और यहाँ कितनी कैटेगरीज हैं, कैटेगरी 1 2 3 4 5 कैटेगरीज। तो इसका मतलब ये है कि चाहे नंबर ऑफ कैटेगरीज कितनी हो, तो काई स्क्वायर टेस्ट इज independent of number of categories in the variable. ओके, आई होप आपको ये चीज समझ में आ गई है। ठीक है, वहां पे तो ऐसे था ना कि 2 कैटेगरी तो टी टेस्ट लगेगा, 2 से ज्यादा कैटेगरीज हैं तो अनोवा लगेगा। नॉन पैरामीट्रिक में अगर 2 कैटेगरीज हैं तो मान विटनी यू टेस्ट लगेगा, और अगर 2 से ज्यादा कैटेगरीज हैं तो क्रुस्कल वैलिस टेस्ट लगेगा। बट नाउ इन दिस केस ऑफ chi square, so whatever the number of categories are in both the variables, okay, the chi square test will not change. Okay, I hope that you got me here. And now going further, let's take one more example and do the chi square test again. Okay, so let's take some other example of chi square test. Which example should we take? Gender and preference of car, ये भी लिया जा सकता है ना, ये भी लिया जा सकता है। प्रोफेशन एंड प्रेफरेंस ऑफ कार, क्या ऐसा है कि एक पर्टिकुलर प्रोफेशन एक पर्टिकुलर कार ब्रांड को प्रेफर करता है? बिजनेसमैन नहीं खरीदते मारुति की कार या हुंडई की कार, बिजनेसमैन खरीदते है ना। एज कैटेगरी को भी हम कर सकते हैं, एज कैटेगरी एंड स्मोकिंग स्टेटस, एज कैटेगरी हम किसी को भी कर सकते हैं। मेल्स, जेंडर एंड स्मोकिंग स्टेटस, क्या जेंडर और स्मोकिंग स्टेटस के बीच में रिलेशनशिप है, हम ये भी कर सकते हैं। तो चलिए ये देखते हैं कि प्रोफेशन और प्रेफरेंस, क्या प्रोफेशन से whether the profession influences the preference of people. So what would be the null hypothesis? The null hypothesis is there is no significant association between profession and the preference of car brand. Okay, four-wheeler or sedan or car, whatever your study is all about. So the profession is not associated with preference of car brand. So how we'll do this? So go to analyze, go to descriptives and go to cross tabulation, reset, and then profession. Okay. So according to your logic, which is dependent variable? Is it profession or is it car brand? It's car brand. क्योंकि ऐसा तो नहीं है कि मेरा ये कार का ब्रांड है इसलिए मुझे गवर्नमेंट जॉब कर लेनी चाहिए, ऐसा नहीं हो सकता ना, है ना। कोई बोले मेरे पास तो टाटा की कार है इसलिए मुझे बिजनेस खोल लेना चाहिए अपना, इट्स नॉट लाइक दैट। बट ये जरूर होता है कि मेरा प्रोफेशन ऐसा है तो आई शुड, हो सकता है ना, कुछ तो एसोसिएशन हो सकता है, मगर साफ लगता है कि डिपेंडेंट वेरिएबल ब्रांड प्रेफरेंस है। अगर अच्छा दोनों केसेस में जो प्रोफेशन है वो इंडिपेंडेंट हो गया है ना। देखिए ये वाला केस देखिए जिसमें प्रोफेशन डिपेंडेंट लगता है, जैसे जेंडर और प्रोफेशन के बीच में मैं एसोसिएशन देखना चाहता हूँ। कहीं ऐसा है कि एक पर्टिकुलर जेंडर एक पर्टिकुलर प्रोफेशन को प्रेफर करता है। So I would like to see whether there is association between gender and profession. तो अगर हम ध्यान से देखें तो लगता है कि हाँ जेंडर पर प्रोफेशन डिपेंडेंट है, मींस प्रोफेशन इज डिपेंडेंट। ऐसा नहीं हो सकता मैं गवर्नमेंट एम्प्लॉय हूं तो मुझे अब मेल बन जाना चाहिए, इट्स नॉट पॉसिबल ना। मैं बिजनेसमैन हूं, मैं होम मेकर हूं तो मुझे फीमेल बन जाना चाहिए, इट्स नॉट पॉसिबल। And what is the possible, which is the opposite, like I am a female, so I should actually try for government job first. The chances are more. So in that case so dependent variable here will be profession, so then profession will come in columns. So you must understand this, there must be some logic. Okay, तो आई होप आपको चीजें समझ में आ रही। आगे बढ़ते हैं और कुछ नहीं करना, स्टैटिस्टिक्स में हम काई स्क्वायर को कंटिन्यू करेंगे। सेल्स में हम कहेंगे हमको एक्सपेक्टेड भी मत दो, छोड़ो अभी नहीं चाहिए, या करें? चलो देखते हैं, एक्सपेक्टेड भी कर देते हैं, कंटिन्यू। फॉर्मेट वगैरह कुछ नहीं चाहिए, क्लस्टर बार प्लॉट भी मत दीजिए, सिर्फ रिजल्ट दीजिए। ओके किया, and here comes the ये बहुत अच्छा केस आ गया हमारे पास। आपको 2-3 चीजें एक्स्ट्रा बतानी है इसमें। ये देखिए, तो सबसे पहले तो क्रॉस टैबुलेशन। क्रॉस टैबुलेशन इज, ध्यान से सुनिएगा, क्रॉस टैबुलेशन में देखिए here this business, okay, business people who do business and they prefer Hyundai R2, they prefer Maruti 6, Tata 3, and then private employee 6, 14, 2. It's like that. Now let's see so this is the cross tabulation, simple cross tabulation, समझ में आता है? This is observed frequency, this is expected frequency, observed, expected. Now coming on to their chi-square test, this table, just see here, ये देखिए chi-square test में this is the value of chi-square, this is the value of chi-square, and this is the degree of freedom, and this is the value of P. What is the P value? P value is greater than 0.05. So null hypothesis accepted. What was the null hypothesis? कि देखिए साहब, profession और preference ये रिलेटेड नहीं है, एसोसिएटेड नहीं है, और ये एक्सेप्ट हो गया। ओके, इट मीन्स दैट वाकई में there is no association between what profession you follow and what car you are going to buy, but ये रिजल्ट को मान नहीं सकते आप, कुछ प्रॉब्लम है, एक प्रॉब्लम है यहाँ पर, और वो प्रॉब्लम क्या है, ध्यान से सुनिएगा। वो प्रॉब्लम ये है कि यहाँ पर देखिए क्या लिखा हुआ है, ये देखिए यहाँ इधर, what is written here? It is written 10 cells have expected count less than 5. The minimum expected count is 1.34. इसका मतलब ये है 10 सेल क्या आप छोड़ दीजिए, इवन इफ इट इज 1 सेल, इसको इस सेल कह रहा है। 10 सेल का मतलब 1 सेल, 2 सेल, 3 सेल, ऐसे कह रहा है, इसको सेल कह रहा है, एक खाने को जहां पर लिखा हुआ है। ओके, ये कहता है कि इसमें एक्सपेक्टेड काउंट जो है ना वो 5 से कम है। काई स्क्वायर टेस्ट की एक कंडीशन है, कंडीशन ध्यान से सुनिए, क्या कंडीशन है? कंडीशन ये है कि ऑल दी सेल्स इन दी क्रॉस टेबुलेशन, ठीक है, हैव मिनिमम एक्सपेक्टेड फ्रीक्वेंसी ऑफ 5। अगर 5 नहीं, ये तो 10 है ना, अगर एक में भी है प्रॉब्लम तो आप नहीं कर सकते, तो आप काई स्क्वायर टेस्ट नहीं लगा सकते। तो आपका क्वेश्चन होगा फिर क्या करें सर? कुछ नहीं कर सकते आप, आपका रिजल्ट ही गलत है। सिर्फ एक ही तरीका बचता है, ओनली वन वे। व्हाट इज दैट वन वे? इंक्रीज सैंपल साइज। इसके अलावा कुछ नहीं होता। हाँ, एक केस में होता है, अगर दोनों क्रॉस टैबुलेशन जो हो रहा है, इस क्रॉस टैबुलेशन में दोनों तरफ सिर्फ दो कैटेगरीज हो। कितनी कितनी? दो कैटेगरीज, यानी कि यहां सिर्फ प्राइवेट एम्प्लॉय और गवर्नमेंट एम्प्लॉय 2 कैटेगरी थी, और यहाँ पे 2 ही कैटेगरी थी, कौन सी? मारुति और से टाटा, ठीक है, बस ये 2। अगर ये हैं तो फिर हम एक करेक्शन फैक्टर लगा दो, जोड़ देते हैं कि भाई करेक्शन फैक्टर जोड़ दो, क्योंकि 5 से कम है। वो भी हमेशा क्वेश्चन मार्क, उसको बोलते हैं येट्स करेक्शन फैक्टर, लेकिन वो करेक्शन फैक्टर भी डिस्प्यूटेबल है, ठीक है। वो करेक्शन फैक्टर क्या होता है कि आपको करना पड़ेगा ऑब्जर्व्ड माइनस एक्सपेक्टेड माइनस 0.5 होल स्क्वायर, 0.5 होल स्क्वायर डिवाइडेड बाय एक्सपेक्टेड फ्रीक्वेंसी समेशन। तो ये भी आपको करना पड़ेगा, मगर ये भी कई बार इश्यू आ जाता है, इस पे डिस्प्यूट आ जाता है कि नहीं जी मैं तो हमसे नहीं मान रहे। You increase your sample size. The best way is whenever you find this line that the expected count, देखिए यहाँ पे expected count 1.3, 1.7, 2.7, 2.6, 3.3, 2.2, 2.8, 2.8, 2.2, देखिए expected count, ये सब के सब क्या है? प्रॉब्लम्स। क्या है? तो what is the solution? What is the solution? Increase sample size. इसलिए जब भी काई स्क्वायर टेस्ट करें ना, याद रखिएगा सैंपल अच्छा खासा होना चाहिए, सैंपल अच्छा खासा होना चाहिए। आई होप आपको ये बात समझ में आ गई है। तो इसलिए मैं आपको कह रहा था क्या, कि जब थीसिस लिखनी हो तो साहब ये जरूर दिखाना है कि आप अपना एक्सपेक्टेड काउंट भी दिखा रहे हैं, ठीक है। इसलिए आपको क्रॉस टैबुलेशन वाला टेबल दिखाना है। आई होप आपको चीजें समझ में आ रही हैं, ठीक है। आगे बढ़ते हैं। अब हम बात करते हैं, any question as of now? No, wait. So अब हम बात करते हैं अच्छा उसकी तो बात की नहीं हमने। Okay, now let's talk about the when I say that you know that two variables are associated, and those two variables are categorical variable, then what is their strength of association, है ना? कितने strongly associated हैं वो दो variables, ये भी तो बहुत जरूरी है हमें जानना, ठीक है, तो अगर वो एसोसिएटेड नहीं है, so why to check their strength of association when they are not associated? Means when null hypothesis is accepted, means when you are not rejecting the null hypothesis, it means association है ही नहीं, तो strength क्या देखनी? मगर अगर association है, तो इसका मतलब जब हमने देखा था association है, तो हमने कहाँ देखा था association है? वो देखा था हमने प्रोफेशन और स्मोकिंग में एसोसिएशन था ना? जब हमने यहाँ पे देखा था क्रॉस टैबुलेशन में स्मोकिंग और प्रोफेशन में एसोसिएशन था, ठीक है। एग्जैक्ट छोड़ो, कैंसिल छोड़ो, स्टैटिस्टिक्स में काई स्क्वायर कंटिन्यू करो, ओके करो। तो एसोसिएशन अगर हम देखें तो यहाँ पर हाँ नहीं, एसोसिएशन नहीं है, स्मोकिंग हैबिट और इसमें एसोसिएशन नहीं आया है। तो किस में एसोसिएशन आया था? जेंडर और प्रोफेशन में आएगा एसोसिएशन। देखें जरा, एनालाइज क्रॉस टैबुलेशन, जेंडर और प्रोफेशन में एसोसिएशन है क्या? काई स्क्वायर कंटिन्यू देखें जरा। नो, देयर इज नो एसोसिएशन बिटवीन जेंडर एंड, तो टिक 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 किसमें था एसोसिएशन? प्रोफेशन और स्मोकिंग में भी नहीं था, जेंडर उसमें था, एज कैटेगरी और स्मोकिंग। किस एसोसिएशन तो निकलना चाहिए ना, तभी तो मैं आपको वो स्ट्रेंथ ऑफ एसोसिएशन बताऊंगा। स्मोकिंग और प्रोफेशन और एज कैटेगरी एंड स्मोकिंग देखते हैं एक बार। एज कैटेगरी एंड स्मोकिंग, एज कैटेगरी एंड स्मोकिंग हैबिट, ओके। नो, किसी में भी एसोसिएशन नहीं आ रहा है, ओके। और हम देखें किसी और में, देखें प्रेफरेंस और एज कैटेगरी में देखें, मुझे तो नहीं लगता इसमें भी आएगा। प्रेफरेंस, ब्रांड प्रेफरेंस और एज कैटेगरी में, अरे एक में किस में आया था? जेंडर एंड स्मोकिंग में देखते हैं एक बार। जेंडर एंड स्मोकिंग, जेंडर एंड स्मोकिंग हैबिट, यस आ गया। तो ये देखिए, जेंडर एंड स्मोकिंग में देयर इज एन एसोसिएशन। इफ यू सी हियर, ओके, gender, male and female, and smoking habits. So it has been found that females ज्यादा स्मोक कर रही हैं और मेल्स कम स्मोक कर रहे हैं as per the data. Okay, so here if you see the chi-square value is less than 0.05, है ना? 0.05 chi-square value, so just see it is less than, है ना? Less than 0.05, it means null hypothesis rejected. और null hypothesis क्या था कि gender and smoking habit are not associated but rejected. It means they're associated. So what is the strength of association? What is strength of association? So to actually find out the strength of association, we have something called this. This contingency coefficient, phi and Cramer's V. Okay, so let's first see phi and Cramer's V. What is contingency? तो दोनों ही देख लेते हैं, ये इनका मतलब क्या होता है देखते हैं भैया। कंटिन्यू, ओके। अब देखिए, now they are associated, that can be shown from this particular p value. Okay, they are associated. So now what is the strength of association? Okay, the strength of association is, just see this, the phi value, Cramer's V value, and what is this contingency coefficient? Okay, so the value of this phi, Cramer's V, and contingency coefficient, it varies from 0 to 1. Okay. If the value is this value lies near to 0, it means less strength of association, low strength of association. ठीक है? Or if in case if it is near to 1, the high strength of association. Okay, so then you may be having a question कि sir phi देखना है, Cramer's भी देखना है या contingency coefficient देखना है. Now there is a condition for that कि आपने कौन सा देखना है. मैंने तो तीनों इकट्ठे देख लिए. कंडीशन क्या है सुनिए. If the cross tabulation is square, cross tabulation is square and 2 by 2 means दोनों में दो ही, इन दोनों में यानी कि मेल फीमेल दो कैटेगरी और वहां क्या था स्मोकिंग यस और नो. सो ये क्या हो गया 2 by 2 है ना. तो जब भी क्रॉस टैबुलेशन 2 by 2 यानी कि दो वेरिएबल्स के बीच में आप एसोसिएशन देखना चाहते हैं एंड दिस एसोसिएशन and both the variables have 2 categories each, then we use phi coefficient. तो हम क्या यूज करते हैं phi coefficient. समझे आप? ग्रेट. सो दिस इज वन. नाउ तो ये क्रैमर्स भी कहां होता है? क्रैमर्स भी होता है, क्रैमर्स भी जब उनके बीच में एसोसिएशन है मगर 2 by 2 का क्रॉस टैबुलेशन नहीं बन रहा. अभी हमने किया था ना स्मोकिंग हैबिट, स्मोकिंग यस और नो, और प्रोफेशन में कितने थे 5. बिजनेस, गवर्नमेंट एम्प्लॉय, प्राइवेट एम्प्लॉय, प्रोफेशन, होम मेकर. तो इसकी कोई स्क्वायर टेबल 2 by 2 तो बनेगी नहीं. इसकी कैसी बनेगी? रेक्टेंगल, है ना. ऐसे बन जाएगी टेबल. या तो ऐसी बनेगी, ऐसी लंबी, या फिर ऐसी लंबी, डिपेंडिंग अपॉन कि आपने किसको रो में लिया और किसको कॉलम में लिया. ठीक है ना जी. तो ऐसे केस में आप क्रैमर्स भी यूज करेंगे. ठीक है, समझ में आया आपको? ओके. तो कंटिंजेंसी कोएफिशिएंट कहां करेंगे? कंटिंजेंसी होता है कि आप किसी में भी कर सकते हैं. एनी, बी इट स्क्वायर ऑफ एनी साइज एंड रेक्टेंगल ऑफ एनी साइज. समझे आप? सो ये आप करते हैं कंटिन्यूसली. इसकी स्ट्रेंथ ऑफ एसोसिएशन देखने के लिए आप सोचेंगे सर इस स्ट्रेंथ ऑफ एसोसिएशन का क्या करें? कर सकते हैं. वो डिपेंड करता है. कई बार क्या होता है आपको एक चीज को दो चीजों के साथ एसोसिएट करके देखना पड़ता है. जैसे दिस इज इवेंट 1, दिस इज इवेंट 2, और ये एक ऐसा वेरिएबल है जिसको आप इससे एसोसिएट करके देखना चाह रहे हैं. ठीक है, इस इवेंट के साथ. पहले इस वेरिएबल को आपने इसके साथ एसोसिएट करके देखा, स्ट्रेंथ ऑफ एसोसिएशन आया 0.509. इसके साथ करके देखा तो आया 0.709. तो आपने कहा ये वेरिएबल इस इवेंट के साथ ज्यादा एसोसिएट होता है. यानी कि ऐसा मेडिकल साइंस में कहीं भी किया जा सकता है. इसलिए स्ट्रेंथ ऑफ एसोसिएशन देखना है. अदरवाइज आप प्रिडिक्ट कुछ नहीं कर सकते. प्रिडिक्शन करना इज नॉट दैट इजी फॉर categorical variables. However, there are methods of predictions. भाई मशीन लर्निंग क्या है? डिसीजन ट्री क्या होता है? डिसीजन ट्री यही तो है मशीन लर्निंग में. रोबोट्स कैसे डिसीजन लेते हैं, है ना. कार, जो ड्राइवरलेस कार्स हैं वो कैसे डिसीजंस लेती हैं. ठीक है, जब कैटेगोरिकल वेरिएबल्स आते हैं उस कार के आगे जिसमें ड्राइवर नहीं है, तो वो कैसे प्रिडिक्ट करती है? तो वो इन सभी मेथड्स को यूज करती है मशीन लर्निंग में. ओके, आई होप आपको चीजें समझ में आ गई हैं. ठीक है, और एक चीज आपको मैं बताता हूं कि ये लैम्डा क्या है. ये भी बड़ा इंटरेस्टिंग है काई स्क्वायर में. काई स्क्वायर में बहुत कुछ सीखने का है, इसलिए मैंने काई स्क्वायर लास्ट में लिया। तो काई स्क्वायर में अगर हम बात करें तो क्रॉस टैबुलेशन में ये देखिए, देयर इज समथिंग कॉल्ड इन स्टैटिस्टिक्स, देयर इज लैम्डा। इसको हटाइए और लैम्डा को देखिए यहाँ, ठीक है। इसको कंटिन्यू कर देते हैं और सेल्स को हटाते हैं पहले यहाँ से, हमें कुछ मत दो ना, ऑब्जर्व कोई फ्रीक्वेंसी मत दो, ठीक है, कैंसिल, और इसे ओके कर दो। तो यहाँ देखिए, ये बहुत अच्छी चीज है। क्या कहता है, ध्यान से देखिए, ये कहता है कि डायरेक्शनल मेजर्स हैं। लैम्डा का मतलब होता है, ये कहता है कि आप इनमें से याद, आप ये गुडमैन एंड क्रुस्कल टाउ नहीं लेना है, आपने गुडमैन एंड क्रुस्कल टाउ को इग्नोर करना है। ये SPSS क्योंकि पैसा लेता है ना बहुत, तो हम चीज एक मांगते हैं, ये एक से ज्यादा दे देता है, कहता है तुमने मुझे पैसे दिए हैं ना, इसलिए मैं तुमको बहुत सी चीजें एक प्लेटर में दे दूंगा। तो ये बेचारा इज सो कंसीडरेट है ना, सो जेंटल, तो इसलिए हमने तो मांगा सिर्फ लैम्डा था। तो अब लैम्डा की अगर हम बात करें तो देखें ध्यान से, लैम्डा कहता है कि ये देखते हैं कि कौन सा लॉजिकली डिपेंडेंट है और कौन सा इंडिपेंडेंट है। तो क्या करता है, इट सेज कि यू टेक जेंडर एज डिपेंडेंट, ओके, you take gender as dependent and see the significance value, and you take smoking habits as dependent and see the significance value. Okay, here in this case, if you see that both are significant, है ना, p value is less than 0.05 here. तो अगर आप जेंडर को डिपेंडेंट लेते हैं तब भी, और आप स्मोकिंग हैबिट को डिपेंडेंट लेते हैं तब भी, तो अब आपका लॉजिक क्या कहता है, आपका लॉजिक ये कह रहा है कि भाई जेंडर डिपेंडेंट नहीं होगा, स्मोकिंग हैबिट डिपेंडेंट होगी, और मेरा लॉजिक और ये रिजल्ट कोइंसाइड कर रहे हैं और ये सिग्निफिकेंट है। ऐसा नहीं है कि जेंडर को अगर मैं डिपेंडेंट कर देता हूं तो वो सिग्निफिकेंट आता है, अगर मैं जेंडर को इंडिपेंडेंट करता हूं तो इनसिग्निफिकेंट आता है। तो आपने जिसको डिपेंडेंट बनाया था वो स्टैटिस्टिकली भी एसोसिएटेड है और रिजल्ट सिग्निफिकेंट है, ये मतलब होता है लैम्डा का। ओके, तो ये सब चीजें हैं जो कि आपको आनी चाहिए। अच्छा, अब रहेगी कौन सी चीजें, वो अब रह गया कि ये जो बचा, एनालाइज, डिस्क्रिप्टिव, cross tabulation, and go to statistics and see this gamma, Somers D, candle tau. What is this? Now this Somers D and gamma, ये ये candle tau B and candle tau C, ये चारों strength of association बताता है। Only gamma is same as lambda here. Gamma talks about dependency, and this candle tau and candle tau B and C, they both are, they talk about the strength of association between the variables. Now, what is the difference then? What is the difference between phi and Cramer's V and candle tau and candle V? The only difference here is very simple. It is ordinal data, it's nominal. Now, what is ordinal and nominal? देखिए ध्यान से, ये देखिए, ये जो आप वेरिएबल देख रहे हैं ना, जेंडर, ये कौन सा वेरिएबल है, जेंडर नॉमिनल वेरिएबल है, ठीक है, नॉमिनल है। मगर एज कैटेगरी को देखिए, ये नॉमिनल तो है मगर साथ में इसमें एक और चीज है, ऑर्डर है, असेंडिंग और डिसेंडिंग ऑर्डर में लिख सकते हैं हम इसे, 18 to 25, 26 to 35, 36 to 45 and above 45. देख रहे हैं आप, any variable where the categories can be written in ascending or descending order, then that variable becomes ordinal variable. तो जब भी आप एसोसिएशन देख रहे हैं एज कैटेगरी और से स्मोकिंग के बीच में, ये है तो दोनों कैटेगोरिकल, बट एज कैटेगरी इज ऑर्डिनल, सो वी शुड गो फॉर कैंडल टाउ बी और कैंडल टाउ सी, कैंडल टाउ बी और कैंडल टाउ सी। अब ये बी और सी कहाँ यूज होगा, बी यूज होता है 2/2 ऑर्डिनल में और सी होता है रेक्टेंगल में, 2/3, 3/4 रेक्टेंगल, क्रॉस टैबुलेशन में, ऑर्डिनल में कैंडल टाउ सी यूज होता है, तो ये कम ही यूज होते हैं, ठीक है। सो दिस इज व्हाट यू नीड टू नो अबाउट काई स्क्वायर टेस्ट। नाउ काई स्क्वायर टेस्ट एक जगह और भी होता है और उसका नाम है पेयर्ड सैंपल। पेयर्ड सैंपल, यस। अभी जब हमने टी टेस्ट किया था पेयर्ड सैंपल में और हमने विल्कॉक्सन साइन रैंक टेस्ट किया था, वहां पर किस केस में किया था आपको याद हो तो? केस ये था, वेट बिफोर एंड वेट आफ्टर ट्रेनिंग, यही था ना, यही केस था, है ना। और फिर हमने वहां पर टेस्ट लगा के देखा था कि इज देयर एनी इफेक्ट ऑफ ट्रेनिंग और नॉट। बट नाउ हियर इफ यू सी स्मोकिंग बिफोर एंड स्मोकिंग आफ्टर ट्रीटमेंट, यहां कैसे करेंगे आप? दोनों के दोनों कैटेगोरिकल हैं, सो ये भी पेयर्ड तो है मगर कैटेगोरिकल है। यहाँ टी टेस्ट विल्कॉक्सन साइन रैंक नहीं लगेगा, तो यहां पे क्या लगेगा? मैकनेमार टेस्ट। मैकनेमार टेस्ट ये कहां है? ये देखिए, ये इधर ही है, देखिए, एनालाइज डिस्क्रिप्टिव क्रॉस टैबुलेशन स्टैटिस्टिक्स में, ये देखिए ये रहा मैकनेमार। तो हम कैसे करेंगे? हम यहाँ पे इसको रीसेट करते हैं। हम स्मोकिंग हैबिट एंड स्मोकिंग स्टेटस आफ्टर ट्रेनिंग कॉलम, है ना। तो ये किया, स्टैटिस्टिक्स पर गए, मैकनेमार काई स्क्वायर, कंटिन्यू, ओके। नाउ here comes the, so this is the cross tab, see the cross tabulation of yes and no, see the cross tabulation, okay. Smoking habit and weight after, हमने कहीं गलती कर दी है ना? स्मोकिंग हैबिट एंड वेट आफ्टर कर दिया, आपने बताया भी वेट कहाँ गया? स्मोकिंग वेट आफ्टर ट्रेनिंग ले लिया, आप बता भी नहीं रहे हो स्मोकिंग एंड स्मोकिंग स्टेटस आफ्टर ट्रेनिंग, ये करना था, ठीक है। स्टैटिस्टिक्स में काई स्क्वायर एंड मैकनेमार, कंटिन्यू एंड ओके एंड सी। सो दिस इज द मैकनेमार टेस्ट, ये देखिए ये रहा, यहां और कोई टेस्ट नहीं चलेगा, ये वाला टेस्ट चलेगा, मैकनेमार टेस्ट। So smoking before and smoking after treatment, is there any difference? So what is the null hypothesis? No, there is no effect of treatment, क्योंकि भैया स्मोकिंग पर कोई असर नहीं पड़ा, but p value is less than 0.05, which means rejected, null hypothesis rejected, इसका मतलब फॉल्स, इफेक्ट पड़ा है ट्रीटमेंट का। आई होप आपको चीजें समझ में आई हैं, ठीक है। सो दिस इज ऑल अबाउट काई स्क्वायर टेस्ट। अभी एक टेस्ट बच गया जो कि इसमें नहीं लिखा हुआ, किसमें? इस पीपीटी में नहीं लिखा हुआ। कौन सा टेस्ट है वो, अगर आपको पता हो तो? जब मैंने करवाया था, मैंने करवाया भी है, आपको बताया भी है, आपको कुछ ध्यान नहीं है लगता। सो वो टेस्ट है when we actually go for two variables and both are numeric in nature, that is Karl-Pearson coefficient of correlation, but what is the assumption? Both should follow the normal distribution, both should follow the normal distribution. So normal distribution कैसे होगा? अगर normal distribution नहीं हुआ तो then which particular test we should go for? Spearman rank correlation, समझे आप? तो मैं अगर ये देखना चाहता हूं कि क्या वेट और कैलोरी इनटेक के बीच में रिलेशनशिप है, क्या ऐसा है कि जो लोग ज्यादा कैलोरी खाते हैं उनका वेट बढ़ता है, या फिर ये सिर्फ वहम है? तो मैं देखना चाहता हूं but calorie intake is not normally distributed. Let's assume अगर अगर normally distributed होता तो हम तो बड़ा simple सा correlation test कर लेते, है ना? So what is the null hypothesis? Null hypothesis is no, there is no impact of calorie intake on weight. That, or we can say that there is no relationship between calorie intake and weight. So go to analyze, go to correlate, go to bivariate, okay? And instead of Pearson, instead of candle tau B, just say Spearman and take both the variables, calorie intake here and weight here, okay? And say okay. Now, is there any relationship? Yes. What is the p-value? Just see here. What is the p-value? Less than 0.05. Yes, they are significantly related. But what is the strength of correlation? 0.313. If it is near to 1, that we know. And if it is near to 0, so weak correlation है हमारे डेटा के हिसाब से, है ना? वीक कोरिलेशन है किसके बीच में? कैलोरी इनटेक एंड वेट के बीच में. ओके, सो दिस इज हाउ यू डू स्पीयरमैन रैंक कोरिलेशन. स्पीयरमैन रो, है ना? रो, RHO कैसे लिखते हैं? ऐसे, ऐसे, है ना? तो ये है हमारा नॉन पैरामेट्रिक टेस्ट. ठीक है, लोग समझते हैं कि नॉन पैरामेट्रिक टेस्ट ऐसे ही है, बट नॉट. इट इज ऑफ हाई यूज, इट्स ऑफ हाई वैल्यू. मोस्ट ऑफ द रिसर्चेस people use non parametric, and majority of them use chi-square. Okay, thank you so much. Now any questions, please, if you have.
Participants, if you have any questions, please write into the chat box.
You can write or you can speak as well.
Anyone?
Respected. Thank
One
you.
question is from my side. I'm Dr. Bhavika Thakkar. Sir, actually, if Likert scale is there, so that data is with the quantitative, not quantitative data for us, right? So at that time, normality, for checking normality, the same procedure, whatever you have explained, that we can apply, or something different for that?
देखिए हर्षिल मैम, when Likert scale, when you talk about Likert scale, Likert scale is a scale. One, what does that mean? Why you are calling it as a scale? Why you are not calling it as a variable? Because it's a set of statements which come together and make a construct and make a scale, make a parameter. Okay, so Likert scale is also known as summated scale. So what do? You actually take the sum of all the responses for all the statements for a particular respondent, and then you take the average of that particular respondent. That becomes the score of that respondent of that particular scale. So that score is a continuous data. Okay. Now, Likert scale variable per se, one statement is useless. It has no meaning at all. That is why you need to be very careful. When you say Likert, you also add a suffix, that is scale. So when you say scale, it means set of statements. It's not one statement. If it is one statement, then it should not be a scale. It should be a variable. Okay, ma'am. So Likert scale in itself is an interval scale, but that particular statement. But when you take the sum of all the responses and take the average. That becomes the score. And that score is a continuous score. Okay, ma'am?
Okay. Thank you so much, sir. Thanks a lot.
Okay. Any other question?
Any
Okay.
questions, participants?
Great. या तो सब कुछ समझ में आ गया या कुछ समझ में नहीं आया.
Sir, actually you have explained very nicely in depth. Actually इतना डिटेल में कोई नहीं बताता है जितना आपने अच्छे से बताया है. Actually I know subject a little bit, so I understand that you have given lots of ideas and very patiently you have covered entire aspect. Thank you so much for all, sir.
Thank you, ma'am. Okay.
Sir, actually all the concepts that were in chi-square, we never knew the meaning of it. So that was the best part. Last part was the best part. Like we came to know about everything. ये टेस्ट क्या करता है, ये टेस्ट क्या करता है. We just used to tick whatever is required. बस उतना पता था.
Okay, that's great. I'm happy that now you know it. That's great. People who are actually who are writing thesis, it's of very much use. I'm telling you, they should use it. People who are writing papers, it's not required that much. Okay, Ji. Anything else? Thank you.
Really, SPSS is such a wonderful and powerful tool for
Yes.
researchers.
Yes, absolutely.
Yeah, it's very powerful.
It's very
So, thank
powerful
you
and
so
it's very
much.
expensive.
Yes. Even the trial version is there, sir, but still all the parameters and features will be available in real version.
Full paid version.
Full version. Yes.
And
yes.
otherwise, pirated I would never recommend. But let me tell you that R as a software, as a statistical analysis software, is far more powerful than SPSS and far more friendly. The only thing is you need to learn it. For sometimes you may struggle for first 2 months, for first 3 months, but after that you will never look back and you will never go and visit SPSS. So,
Yes, sir,
and R is absolutely free. You don't have to do anything else. You don't have to go to any other software, including a MOS, including Smart PLS, including VOS Viewer. You don't have to go to anyone because R is there with you. So R is that excellent software. So try to learn R as well. And I would suggest the organizers of this particular event that do a workshop on R as well for all the participants.
Definitely, sir.
That's great.
Sir, thank you so much for your super informative hands-on session, sir. And really, it was an informative session. So here I take the opportunity to thank the management for allowing us to organize such sessions. Many thanks to our in-charge principal, Dr. Neetu Kapoor ma'am, for her support. And thank you so much, Dr. Savita Punjabi ma'am, for your coordination. And many more thanks to participants. And now, shall I declare the session is over?
Yes.
Yes, Savita ma'am.
Yes, ma'am. Yes.
Yeah. So
Thanks
thank
a
you
lot,
so much.
sir.
Thank you.
Thank you, sir.
Participants, please fill the feedback form. Link is given in the chat.
Yes, tomorrow is the last day. We want few participants for the feedback. Please message on the group if at all you are ready. All those who have attended sincerely, we'll be sharing all the recordings, of course, and all the PPTs as and when we are getting. I have already transferred, but I request few participants to be ready with the feedback and just message us so that we can put up our schedule accordingly. Rushali ma'am, you can wind up.
Yes, ma'am.